In this lesson, we'll take a look at writing parallel and perpendicular lines. This is something that we learned last year in our algebra class, but it's perfect to review. Remember that when writing a linear equation from a graph, we want to identify the slope-intercept form of the equation. So that's always in y equals mx plus b, where m is the slope and b is the y-intercept. We're going to write an equation of the line given this graph. So first we want to identify the slope. So I'm using my rise and run. So I'm dropping down 1, 2, 3, 4, 5, 6. And I'm running 3. But when I drop down, my slope is negative. And I want to simplify this. Negative 6 divided by 3 equals negative 2. I also want to remember point slope formula. Point slope formula is y minus y1 equals your slope x minus x1. The x1 and the y1 are given from a point, and our slope goes in for m. So if we want to write an equation of the line given our graph, we have a point that we're going to pick from the line. So we can pick any point. I'm going to use this point up here. And I'm going to plug that into my point slope formula and rewrite and use the slope given. So I have y minus y1 equals my slope x minus x1. As I simplify this, we get y minus 4 equals negative 2x, and negative 2 times 0 is just 0. Add my 4 to both sides, and I have my equation of y equals negative 2x plus 4. This is the equation for the line given. You also remember that a y-intercept, the y value of your y-intercept, is the b value in our equation. So I could just go ahead and take a look at my line and see where it crosses the y-axis at. It goes up here at 4. That's the y value, and whatever my slope is, that goes in for m. Next, we're going to graph a linear equation. We need to put this in slope-intercept form in order to graph it. So I'm going to subtract 3x on both sides. And then divide each segment by 4 for each term. And my equation will be y equals negative 3/4 x plus 3. This I can then put on my graph. I start with my y-intercept, which is up at 3. And then I use this slope to drop down 3, but run to the right 4. And then you would draw a line through those two dots. You can also remember, you can just graph with y-intercept. So if my equation is in standard form like this one, I'm going to make my x value 0 and solve for the y value. In this case, your y value is 3. And then I'm going to make the y value 0 and solve for the x. The x value is 4. These are my y-intercepts. So up at my graph, it's going to cross the y-axis at 3. It's going to cross the x-axis at positive 4. So you can graph either way. When we want to write an equation of a line that is parallel to a given line and going through a specific point, we want to remember that parallel lines have the slopes that are the same. So first I'm going to look at my equation and identify the slope of the line. In this case, my slope is 2. If I'm looking for a parallel line, the slope would be the same, and the point they want it to go through is given to me. If I want to write the equation of the new line, I'm going to use that point slope formula. Y minus y1 equals my slope, x minus x1. And notice it's x minus, and my x1 is negative 1. This becomes a big old plus sign as we simplify. I'm going to distribute first, and then add 1 to both sides. The equation of my line that is parallel to the original and goes specifically through this point is y equals 2x plus 3. If I want to find the line of the equation perpendicular to a given through a specific point, my process is the same, except perpendicular lines have negative reciprocal slopes. I look at the slope of my original equation, it's negative 2, and I'm going to write it as a fraction, negative 2 over 1. The slope of my new line is its reciprocal flipped upside down, and its opposite sign. So the slope of my new line will be positive 1/2. The point on the line is what's given to me in my equation. And again, I'm going to plug it into that point slope formula. So I have y minus 3 equals my slope. And this is the slope of the new line, not the old line. So perpendicular, and x minus 2. And we're going to go ahead and distribute. Sometimes this can get a little bit tricky with fractions, but half of negative 2 is negative 1. And then we're going to add 3 to both sides. Oops, I changed that to a 3. Let's fix that. Y equals 1/2 x, and then adding 3 to both sides, we'll get plus 2. Go ahead and pause the video, and then you try your examples. We take a look at our first one. We have our equation graphed. On our second one, we're working on using intercepts and then drawing our line. You could change that equation into y equals form and then graph it. And then we're writing an equation of the line that passes through this point parallel to this. So before I can figure that out, I'm going to need to solve for y so I know what my slope is. We're going to subtract 10x on both sides first, and then divide by 4 everywhere. And simplify. So our equation is y equals negative 5/2 x minus 2. That's my original. I'm going to use the same slope and put it into point slope formula. So I have y minus 1 equals negative 5/2 x minus a negative 2, which becomes a big plus. Distribute your fraction. And add 1 to both sides. To get our equation. As we work on our perpendicular line, it's the same process. This one's given to me in point slope formula. I don't need to do much because it gives me the slope right here. So my original slope is 2. When I change it to its negative reciprocal, it's going to become positive. Positive 1/2. So this is the slope that I need to use. This is the point. So again, I'll put it into point slope formula. And distribute my slope and add 3 to both sides to get our new equation for the line that is perpendicular to the original given. We'll take a look at the perpendicular line theorems. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. If two lines are perpendicular, then they intersect to form 4 right angles. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. We have the perpendicular transversal theorem, which says if a transversal is perpendicular to one of the parallel lines, then it is perpendicular to the other. And we have the lines perpendicular to a transversal theorem. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. We have a proof for each one of these. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. 1 and 2 are a linear pair, that's given. 1 and 2 are supplementary, that's the definition of a linear pair. 1 plus 2 is 180, definition of supplementary angles. 1 and 2 are congruent, that's given. Measure 1 equals the measure of angle 2, that's definition of congruent angles. The measure of 1 plus the measure of 2 equals 180, substitution. Then we're combining like terms and then dividing. So we have the measure of angle 1 equals 90. Angle 1 is a right angle, definition of a right angle. Therefore, G is perpendicular to H, definition of perpendicular. We also have quite a lengthy proof to prove that if two lines are perpendicular, then they intersect to form 4 right angles. And a proof for if two sides of adjacent acute angles are perpendicular, then the angles are complementary. We have a proof for perpendicular transversal theorem. And one for lines perpendicular to a transversal theorem. We have some examples. It says given angle ABC is congruent to angle ABD, what can you conclude about angle 3 and angle 4? Well, if ABC is congruent to ADB and they both make a linear pair, that means they add up to 180. If they're congruent, then each of these have to add up to 90. And we can conclude then that if ABC is a right angle, that ABD will be also a right angle, and 3 and 4 will be complementary. Find the value of x. Here it is. We have a right angle here, which means all of these are right angles. So we can say 2x plus x equals 90 and solve to find our x to be 30, not 20, 30. Determine which lines, if any, must be parallel in the diagram. If S and T intersect Q and are 90 degrees, S and T will be parallel to each other. Because P and Q intersect line S and are 90 degrees, P and Q will be parallel. Can we identify any other lines that are parallel? Not in this case, just P parallel to Q and S parallel to T. You can also take a look at distance from a point to a line, and understand that distance is going to be that length that is perpendicular to the segment from the point. Distance between two parallel lines is the length of the perpendicular segment joining the two lines. And we use the distance formula, which looks like this. If we're going to find the distance between two lines, first I want to find the slope of each line. So this slope looks like it might be up 1, 2, 3, 4 over 1. And this one is the same. The slope of the perpendicular segment will have its negative reciprocal as its slope. So I now need to find a point from one line, and I need to travel using that slope to get to a point on the other line. So if I go down 1 from here, and I go down 1 but to the right 4, I'm going to hit another point on the line. So this distance here is going to be, that length is going to be the distance between the 2 points. So I have a point at 1, 4, and I have a point at 1, 2, 3, 4, 5, 3. And now I can find the distance between these 2 points. So big square root x minus x squared plus y minus y squared. Oops, this is 1 plus 4 squared is 16. So the distance is going to be the square root of 17, which is approximately 4.1. I'm okay if you leave it as a square root. If we want to find the distance between a point and a line or two lines, we can start by graphing the line given. And graphing our point. We want to find an equation of a line through 4, 1 that will be perpendicular to y equals x plus 1. Well, I know the slope of this is 1, so the line perpendicular to that is going to have a slope of negative 1, and I'm going to use my point slope formula. So I have y minus y1 equals negative 1, x minus 4. And solve for y. That's going to give me my equation of the line that's perpendicular to the given line. So I'm going to go ahead and graph that line. And I'm looking for where those points intersect. And they intersect right here at positive 2, positive 3. I need to now find the distance between 2, 3 and 4, 1. So I'm going to highlight that in red, this point and this point. I need to find the distance. So I can go ahead and do my distance formula. X minus x and y minus y. square root of 8 for my distance between the 2 points. You pause the video and try for yourself. Find the distance between the 2 points. Here I have a point that fits nicely on my grid, and I'm going to calculate how to get to another point. This slope is a -1/1. So the perpendicular slope that I need will be a +1. So I'm going to go up 1 and over 1, up 1 and over 1. Here is a point of intersection. So I'm using these 2 points and I'm finding the distance between the two. So one of my ordered pairs was 2, 0. The other was 4, 2. Using my distance formula, I have 2 minus 0 squared. Oops, let's do x's first. 4 minus 2 squared plus the difference of our y's will be the square root of 8. Next, we have our equation. So we're going to graph our line. Get as many points as needed. And we're going to graph our points. -6 up 4, 1, 2, 3, 4. I want to find the slope of my line, and I want to find its perpendicular slope. So the original slope was -2/1. Its perpendicular slope will be a half. So I'm using that slope to travel up 1 and over 2, up 1 and over 2, up 1 and over 2 to find the point of intersection. So I'm going to use this point and find my distance. This one is -6, 4. This one is 0, 7. Difference of the x's plus the difference of our y's squared and we now have our distance between the 2 points.